Hello kids, welcome to ICSE Chemistry Hub. This is an ICSE Chemistry channel which will surely help you for your grade 10 exams. Please do like, comment and subscribe my channel. Also do share this video with your friends. And also if you have any positive feedback to give us, kindly do so. Please do subscribe our channel at the earliest. Today we are going to start with part 2 of metallurgy. You will be able to find the first part of metallurgy in my video playlist. So please do refer that once before you go ahead with part 2 of metallurgy. So in part 1, we had discussed the various steps that are involved in the extraction of metals, or what were the steps that were involved in metallurgy. Okay. Now, what was metallurgy, children? Metallurgy was involving nothing but when we take out the metal from the earth's crust, we call it as metallurgy. Okay. So, there were 5 steps that are involved in the extraction of metals. Okay. This we have already done in the previous video. Please do have a look at that part 1 of that video. Okay. So the steps that are involved in the extraction of metals are, step 1 is when they get those huge pieces of rock, they crush that rock or they crush that ore into fine smaller pieces, okay, or they powder it. Now how do they do it? They do it with the help of rollers. This process is called as pulverization. Please remember this technical term for it, okay. So step 1 is pulverization. Step 2 is called as dressing of the ore or concentration of the ore, okay. And in my previous video, I have discussed all the steps that are involved in the dressing of the ore or the concentration of the ore. Now, what do you mean by the word dressing of the ore? It means nothing but I am initially trying to purify the ore, okay. So, I can also call it as initial purification of the ore, okay. And we had discussed the various methods that are carried out for dressing of the ore. Okay, if you remember, the first method was hydrolytic method, okay, where we are using water. Second method was magnetic separation, where we are using a magnetic wheel. Third method is the most important method called as froth flotation method. And the last method was called as the chemical method, where we are using a chemical like sodium hydroxide. Today we will be dealing with step 3, step 4 and step 5. Okay. So first we will crush the ore. That's done. Then we have tried to remove as many impurities as possible. Step 3 is converting the ore to its oxide. Okay. As I have told you, if I have any other ore, for example, say I have zinc sulphide, what is the thing that I should do? I should first convert it into an oxide. Now the question is, why should I convert it into an oxide? Because as we know, oxide or oxide is very, very easy to remove. Okay. So whichever form we are getting the metal in, we will first convert it into an oxide. Clear? Then the next step is the reduction of the metallic oxide. We will remove the oxygen element. Okay. So first we are adding oxygen. Step 4, we will remove that oxygen. And we know removal of oxygen is nothing but reduction. Okay. So we have removed oxygen. That means we have got our metal in our hand. So it is removal of oxygen from the metallic oxide so that we get the metal. And the last step is called as electrorefining. We have already discussed this step in detail in the electrolysis chapter. Okay, you can please go through that video where electro means electricity and refining means I am purifying the impure metal to get as much as possible pure metal. Okay. So we are going with step number 3 right now, which is conversion of the ore to its oxide. Now this is a very, very important objective type question. Okay. Now you have to remember there are 2 ways by which a metallic compound can be converted to its oxide. Okay. There are 2 ways by which we can add oxygen. First method is called as roasting. Okay. I want you, if you can see, I have underlined two words here. Okay, so this is how you are going to remember it. So the first method is roasting. The second method is calcination. Okay, so the first method is roasting and the second method is calcination. So if they ask you in the exam, what are the two ways of converting a metal to its oxide? The two ways of adding oxygen to the metallic compound is roasting and the second one is calcination. Now if you can have a look, there are 2 points of difference between roasting and calcination. If you can have a look, I have underlined two words here. For roasting, I have underlined R. R stands for roasting. S stands for sulphide ores. So roasting is always carried out for which type of ores, children? It is always carried out for sulphide ores. So please do remember this. Roasting is carried out for sulphide ores. R, S. Okay, so this is the first point of difference that you have to remember. Roasting is carried out for which type of ores, children? Anything which has got an S inside it. Okay, that is the sulphide. Now comes the second method of converting a metal to its oxide. It's called as calcination. Now what is calcination, children? Look at the words I have underlined. C-A, Ka. So calcination is always carried out for which type of ores, children? It is always carried out for carbonate ores. This is how you will remember it. R-S and Ka. Okay. So roasting is always carried out for sulphide ores. Calcination, on the other hand, is always carried out for carbonate ore. This will be the first point of difference that you have to remember. Second point of difference is there in the diagram itself. When you have a look at the diagram of roasting, what do you see? The substance is heated, the ore is heated. There are very much large number of oxygen atoms. So I'll be using the word excess of oxygen. What is roasting? I am heating the ore in excess of oxygen. Whereas when you see calcination happening, can you see there is very few oxygen atoms that are present. So I will say calcination means I am heating the ore in a limited supply of oxygen. Okay. In roasting, the amount of oxygen is too much, and in calcination, the amount of oxygen is very, very less. So this is the 2 point of difference that you will remember for calcination as well as for roasting. Okay, roasting is RS. What does this mean? Roasting is carried out only and only for which type of ore? Sulphide ores. Okay, so RS, roasting is for sulphide ore, and roasting always happens when there are huge amount of oxygen atom, when it happens in an excess of oxygen. Heating is happening when there is a lot of oxygen that is there. Okay, whereas calcination, Ka. Okay, so remember the short form as Ka. What is calcination? Calcination always happens with carbonate ores. Now what is calcination? Whenever the ore is heated in a limited supply of air, we call it as calcination. Okay, so these are the 2 points of difference between roasting and calcination. Okay. Now, one most important thing that you have to remember is when I am converting the ore, okay, I have initially purified the ore. When I am trying to convert it into its oxide, okay, if the ore is already in an oxide form, okay, you need not carry out this step at all. Okay, so if the ore is an oxide form, we do not do this step at all. So when will we do this step? When the ore is not in an oxide form, we will first convert it into its oxide. Now the question is, why do we carry out this process? Why is it converted into an oxide? It is because oxides are very, very easy to reduce. That means we are able to remove oxygen very, very quickly. Clear? So as told before, roasting, RS, for which type of ores? It happens only for sulphide ores, okay, and it happens in the presence of excess of oxygen or air, okay. Whereas when I say calcination, calcination happens only for which type of ore? It always happens only for carbonate ore, okay. For example, zinc carbonate, iron carbonate, and this happens in the absence of air. That means when the amount of air is very, very less, okay. Now, this is one important question that you will be asked sometimes in the board exam. they will name a carbonate, which gives a residue on heating. So you have to remember, if there's a zinc carbonate from the reactant itself, which gas will be given out, children? Of course, it will be carbon dioxide gas that can come out. From a carbonate, which gas we'll be getting? We can get only carbon dioxide. So what is remaining here? It is zinc oxide. You have to remember the color or the residue color of zinc oxide. It is yellow when hot, white when cold. Clear? So what is the color of zinc oxide? Please remember this. It is yellow when it is hot and it is white when it is cold. Okay, this is the speciality of zinc oxide. Okay. Again, why concentrated ores are converted into oxides? Because oxygen is very, very easy to remove. Okay, oxygen can be removed very, very easily, or in other words, I can say it is easy to reduce. What is the meaning of the word reduce? Reduce means I can remove oxygen very, very quickly. Removal of oxygen is called as reduction. Okay. So the next step that we are going to carry out is, so I have added oxygen. I have completed 3 steps of electrolysis. What is step number 1, children? Step number 1 is I have crushed the ore. Step number 2, I have tried to remove as many impurities as possible. So I have concentrated the ore. Step number 3 is I have converted the ore to its oxide. So what is step number 4 that I need to do, children? I need to remove the oxygen from the metal oxide so that I get the metal in my hand. Okay. So for doing it, you have to remember the reactivity series of metal. Okay. And already I have told you what are the ways, what is that one sentence you will learn to remember this. Okay. Please send cats, monkeys and zebras into lovely hot countries. Signed, General Penguin. Okay. So please stands for potassium. Send stands for sodium. Cat stands for calcium. Monkey stands for magnesium. And stands for aluminium. Zebra stands for zinc. Into stands for iron. Lovely stands for lead. Hot stands for hydrogen. Countries is copper. You can add mercury if you want. Actually, it's not required. Okay, silver and then gold and then comes platinum. So please send cats, monkeys and zebras into lovely hot countries. Signed, General Penguin. Okay, so the most reactive metal is at the top and the least reactive metal will be at the bottom of the series. The same reactivity series of metal will be used while we are trying to reduce the metallic oxide, or in other words, when we are trying to remove oxygen from this metal oxide. Okay. So we have already discussed which are the top 3 metals. Please stands for potassium. Sen stands for sodium. Cats, monkeys. Am I clear? And even and is included, that is aluminium. Okay. So these top 4 to 5 metals. Okay. That is please, sen, cats, monkeys and that is potassium, sodium, calcium, magnesium and aluminium. Okay. You have to remember the points that I am writing here. Okay. The point here is the first point here that you have to, these are the most metallic elements. We know they are very, very highly reactive metals. Okay. These are the top 5 reactive metals. Okay. So the first point that you have to remember here is that they have a, please look at the word I am writing here. They have a strong affinity for oxygen. Am I clear? So they have a very, very huge affinity, strong love for oxygen. The word affinity means nothing but they have a strong affection, they have a strong love, they have a strong attraction for oxygen. So if these metals are there, okay, they will never be ready to leave oxygen out of them. For example, if I have K2O, if I have Na2O, if I have calcium oxide, if I have magnesium oxide, if I have aluminium oxide, all this will have a strong love with oxygen. And because of this strong affinity, okay, because of their strong love for oxygen, they will not be ready to leave that oxygen. Okay, so here I will have to apply the highest possible method. By which method can I remove it, children? I will have to remove it through the method of electrolysis. If I have to remove oxygen, because of their strong connection, because of their strong love, I can only do it with the highest and the costliest method possible. And which is the costliest method that I have? It is electrolysis. Okay. So I hope the first set is clear to you. The metals that are there in the first set are potassium, sodium, calcium, magnesium, aluminium. They have a strong love for oxygen, and because of their strong love, they can be removed only with the help of electrolysis. I have to apply the highest and the costliest method possible. Okay, then I come right after aluminium, okay, and Z-brass, that is zinc, into lovely hot, that is hydrogen, we need not remember that, and countries. Okay, so zinc, iron, lead, copper, they come at the middle of the reactivity series. Okay, why do they come in the middle? Because neither are they as reactive as potassium, sodium, nor are they as inert as platinum or silver or gold. Okay, so when I talk about their affinity also is like that. Okay, so can I say they have got less affinity for oxygen? Am I clear? What do they have, children? They do not have that much affection. They do not have that much love for oxygen. Clear? So I don't have to apply the costliest method for them. Okay, I can just remove it with the help of which kind of agents, children? I will be using something called as reducing agents. Okay, so now zinc, iron, lead and copper, these are the elements which have got middle reactivity, medium reactivity. They are not as reactive as potassium, calcium, magnesium, neither are they as inert as gold or platinum. Okay, so here I'll be applying. Here, remember this, for zinc, iron and lead and copper, their affinity is not that strong. Okay, so or can I say their affinity is less with oxygen. They do not have that strong affinity as potassium, sodium, calcium, magnesium has. So their affinity is comparatively lower. Okay, so I need not apply the costliest method. Okay, costliest method is electrolysis. I will do it for those elements which have got strong affinity. Whereas when I come to the middle one, they do not have that strong affinity. Their affinity is less. So how will I do it, children? I do it with the help of reducing agents. What are reducing agents? They will help the other substance to lose oxygen, or they will add hydrogen into other substance. Okay. Now you have to remember which are the three reducing agents. Which are the three reducing agents, children? First is carbon, second one is carbon monoxide, and the third one is hydrogen. Okay, so I just have to add either carbon monoxide, or I'll be adding hydrogen inside it. Clear? So these are the three reducing agents that I'll be having. Okay, so I hope till here it is clear to you. Top five metals, potassium, sodium, calcium, magnesium, aluminium, they have a very, very strong affection with oxygen. So whenever I'm trying to remove oxygen, I have to apply the costliest method. And which is the costliest method? The costliest method is electrolysis. Okay. When I come to the middle elements, it is zinc, iron, lead, copper. Okay. They do not have that strong affinity, or I can say they have a little less affinity with oxygen. Okay, they do not have that strong an attraction. So I'll be using only what kind of agents here? Reducing agents. And which are the three reducing agents I just now told you? Carbon, carbon monoxide and hydrogen. This carbon can also be called as coke. So which are the three reducing agents, children? Coke, carbon monoxide and hydrogen. Okay, for example, if I have zinc oxide, which were the three reducing agents I told you, children? I can apply the first one, that is carbon. Carbon will have an affinity with oxygen. It will go and attach with oxygen. So what will I get? I will get CO. What is CO? CO is nothing but carbon monoxide and I will get my zinc metal. Okay, so this is one of the ways of removing zinc from zinc oxide. Okay, or for example, say if I have copper oxide, which are the three reducing agents, children? We know it is either carbon, it is carbon monoxide, or it can be hydrogen. So suppose if I add hydrogen, hydrogen will go and combine with oxygen to give me water. What is remaining behind? I have got my copper back in my hand. Okay, so this is how the top 5 metals will react. The removal of oxygen can happen only through electrolysis. When I come to zinc, iron, lead, copper, it does not have that strong an affinity. They are not that strongly attached, so I can remove it with the help of reducing agents. Okay. Whereas when I come to mercury oxide and silver oxide, they do not have any affinity, or I can say they have least affinity with oxygen. Am I clear? Just follow the reactivity series, children. The first 5 metals have a strong affinity. They have a strong love with oxygen. When I come to the middle metals, they have got a little less affinity. Okay? Whereas when you come to mercury and silver, they do not have any attachment, or they have least affinity with whom? They do not have any affinity with oxygen. So the moment you ask them to leave, they are ready to leave. For example, if I have mercury oxide, in your 7th standard, in your 8th standard, many times you must have seen this equation. How can I dissociate or decompose mercury and oxygen? I just have to heat it. What will I get? I will get mercury plus I will get oxygen. Yes or no, children? Okay, so did I apply electrolysis for mercury oxide? No. Did I apply a reducing agent? No. What did I just do? I just applied heat on it and I removed it. Mercury is removed and oxygen is removed. So these two metals, which two metals? Mercury and silver, they have very, very least affinity. They do not love oxygen at all. So the moment they come and combine, what is going to happen? I don't have to do much anything here. I just have to heat the compound. So when I heat the compound, I'll get mercury plus oxygen as my products. Okay. For example, if it is Ag is 1 plus O is minus 2, what will be the formula, children? It will be Ag2O. So when I heat it, I will get 2Ag plus O2. Am I clear? Balancing the equation, I will get 2Ag2O will give me 2Ag plus O2. Am I clear? And this happens only with the two metals, that is mercury oxide and silver oxide. Okay. Now the good thing about platinum and gold and platinum, they are found in pure forms, or in other words, please do remember, they do not form oxides. For example, if I have my gold chain, does it react with oxygen? Does my gold earring react with the oxygen that is present in the air? No. No matter how much ever years would have passed, my gold and platinum will never form an oxide. Oxygen can never go and combine with platinum and gold. So when they do not form oxide, there can be no reduction that can happen here. Okay. So these are the metals, the reactivity series that you need to remember. Once again, quickly revising. Top 5 metals: potassium, sodium, calcium, magnesium and aluminium. They have a strong love for oxygen, or we can say strong affinity for oxygen. Okay, so because the love is very, very strong, I have to apply the costliest method. Which is the costliest method? The costliest method is electrolysis for sure. Okay, now when we come to the middle one, we have elements like zinc, iron, lead and copper. Okay, they have affinity, they do love it, but the affinity is a little less, the love is a little less. So I may not waste my money doing electrolysis here. I can make use of a little cheaper method. So what will I be adding, children? I will be adding any of these three reducing agents. Which are the three reducing agents? Carbon, carbon monoxide and hydrogen. When I come to mercury and silver, please do remember, they have got least affinity. They do not love oxygen at all. Okay. So if by mistake also they come and combine, what do I have to do? I simply have to heat the compound. And when I heat it only, the oxygen will be removed from the compound. Okay. And at the last, you have the last two metals, gold and platinum. We know these are the costliest metals that we get in nature. Okay. Now, why are they costly? Because they do not react. They are mostly found in pure form. They will not form oxides. Clear? So, if there is no oxygen attached to it, I need not waste my money or energy in doing the reduction step. Okay. And the last step is electrorefining of impure metal. Electrorefining is nothing but when we are purifying the metal. Okay. But how are we purifying it? Are we giving it a wash? Are we adding a chemical? No. We are doing it electrolytically. Okay. So when we are doing this process electrolytically, okay, when we are purifying a metal so that we get a pure sample of metal, we call that process as electrorefining. Okay. So this electrorefining of an impure metal has already been dealt with in the electrolysis chapter. If you have any confusion, you can go back there and you can have a look at that video. Okay. So here we have completed all the 5 steps of metallurgy. Clear? So what are the 5 steps of metallurgy? Whenever we are extracting a metal, these are the 5 steps that we will be following. Step 1 is crushing of the ore. What is the technical term given to it? Pulverization. Step 2, what do we try to do? We try to dress the ore, or it is called as concentration of the ore. Okay, we are trying to remove the impurities. Step 3 is we are trying to convert it into an oxide. What are the 2 ways by which it can be converted into an oxide? Either we do it by roasting or we do it by calcination. Okay, then once an oxygen is added to it, our next step will be we have to remove that oxygen. It's called as reduction of the metallic oxide. So when we are reducing the metallic oxide, we are converting it into a metal. And the last step is called as electrorefining. Okay. So in our next class, we will be discussing one metal in detail. Okay. So we will be carrying out the metallurgy of aluminium. Okay. So please do stay tuned because it's a very, very important question for your board exams. So please stay tuned for the extraction of aluminium for the metallurgical processes that is carried out for aluminium metal. Please do stay tuned. Please keep learning, keep revising, and please do like, subscribe and share our videos to others too.